All right, this is question number 3 from the Modern Physics Exam Review. So what number of photons per second is given off by a 50-watt light bulb operating at an efficiency of 4%? And for the purposes of this question, we are going to assume that the wavelength of light from the bulb is precisely 580 nanometers. So it's not necessarily the most physically accurate situation, but maybe imagine that it's like a laser beam of some kind. In any case, we need to figure out what to do here. So we're given 50 watts in the beginning, which is a unit of power. Not really much we can do with that until we see that we're asking photons per second, which is good because we know that 50 watts is really 50 joules per second. And how many seconds? 1 second. So we multiply by 1 second. Seconds cancel, and we are left with 50 joules. But this light bulb is only operating at 4% efficiency, which means we need to multiply this by 0.04, and we are left with a total of 2 joules. So this is an amount of energy we can work with. So now essentially what we're asking is how many photons of wavelength 580 nanometers fit into 2 joules of energy? And this is a question we can answer. So we're going to use Planck's energy frequency relation. And because frequency is just c over lambda, we can say that hc divided by lambda is going to be the energy of a single photon of light. So now, given this information, we will take our 2 joules, we will take our, so number of photons is going to be equal to this 2 joules divided by this quantity over here, so hc divided by lambda. And if we perform this operation, 2 divided by all of these numbers, we find that the number of photons is a ridiculously large number. It's something approaching like 5.8 times 10 to the 18 photons. It's a really large number because photons have a really, really small amount of energy. So 5.8 times 10 to the 18 photons.